Okay, part 2 of worksheet 3, problem number 1. We're done with the hypothesis and the model, and so we're doing the mechanics now. Okay, so mechanics, shape, center, spread. We said we are going to do T model, so let's start with the shape. Shape, okay. Okay, center is at, again, the null is 77 years, so let's write that one. The center is at 77 years. And then shape, center, spread is the standard error, and the spread is from our calculator, it's, where is that? Okay, from our calculator we see that the standard deviation here is 4.4768. So let's get that. 4.4768. Again, don't forget to divide by the square root of the sample size, divided by our sample size is 20. So divided by square root of 1. Okay, so let's move here, or 1.001, or basically it's just 1. Okay, so we got shape, center, and then spread. Next is the data value, and our data value, we look our data value, our x bar is 78.6 years. And so, okay, data value. Next we can compute the again, our degree of freedom is 20 minus 1, or 19, and so we can solve for the t-score now. So t-score, degree of freedom 19, is going to be, again, data value minus mean, so that would be 78.6 minus mean of 77, and then divided by the standard deviation, which is 1.001, or you could do 4.4768 divided by the square root of 20, or, okay, so let's do that, and the calculation. Our t-score is 1.598. okay, so 1.6. So we go here, or 1.60, and so we got our t-score now, and let's just shade that. And this is the two-tailed now. Okay, so our t-score is 1.6, but remember, we don't have any directions. It's just saying not equal to 77, so meaning it could be less or it could be greater. So when we are doing the graph, when we are shading it, this 1.6 could be greater and should be on this side. Could be greater, okay, or it could be lesser or less than. Okay, so this is what we mean by, see this, this is going to be a two-tailed test. Okay, since we don't have any direction. Okay, so let's do the p-value now. And so the p-value p-value, okay, is going to be 2 times the CDF, because we have 2 shaded areas right here. Okay, so that would be 2 CDF, or 2 times the probability that the T is going to be greater than 1.6. okay, so whatever this area, I am going to multiply it by 2, because this is two-tailed test. Okay, and so that would just be 2 times the TCDF, the area, or the left bound 1.6 up to positive infinity, and then the degree of freedom 19. Okay, so let's get that in our calculator. Menu, stat, distributions, TCDF, and lower bound 1.60, upper bound positive infinity, so I'm just going to put big number here, and then the degree of freedom is 19, and I hit OK. So the CDF is 0.063, and remember, okay, let me just write it first. 2 times 0.063. Okay, and let me just do a final computation for that. Multiply it by 2. I'm going to multiply it by 2, and so the final answer would be 12.61%. Okay, let's write that. 0.1261. Okay, that's our p-value. That's a pretty big p-value. That's greater than 5%. Okay, so let's write our conclusion now. Okay, there we go. With a high p-value of 0.1261, higher than 0.05, we fail to reject the null. There is insufficient evidence that the life expectancy has changed. Yay!